Right now, humanity is holding a conversation with a machine that no longer belongs to the solar system. Voyager 1 is drifting through interstellar space, farther from Earth than any object we have ever created, yet it still listens. Every day, faint signals leave our planet, travel for more than 22 hours at the speed of light, and reach a spacecraft built in the 1970s, running on aging hardware powered by a slowly dying nuclear battery. And somehow, that spacecraft answers back. This alone sounds impossible, not because of distance alone, but because space is hostile to information. Signals weaken, noise grows stronger, and precision becomes nearly impossible. So how is it that Voyager 1, now over 15 billion miles away, can still hear Earth at all? And how can Earth still hear something so distant that its signal is weaker than almost anything else we have ever tried to detect? The story begins decades ago, when Voyager 1 was never meant to do this. It was designed for a brief mission to explore Jupiter and Saturn. 5 years, that was the plan. But engineers took advantage of a rare alignment of the giant planets, allowing Voyager to steal energy from gravity itself. As it passed Jupiter, it revealed violent storms and active volcanoes on Io. At Saturn, it uncovered the structure of the rings in the thick nitrogen-rich atmosphere of Titan. Then, instead of continuing along the familiar planetary plane, Voyager 1 turned upward, leaving the flat disk of the solar system behind. That decision changed everything. Over the next decades, Voyager crossed a boundary no spacecraft had ever crossed before, the edge of the heliosphere, the vast bubble carved out by the solar wind. Beyond that boundary, the influence of the sun fades, and interstellar space begins. When Voyager crossed it, its instruments detected a sudden drop in solar particles and a surge in cosmic radiation from outside the solar system. Humanity had, for the first time, touched the space between stars. But touching interstellar space created a new challenge: communication. Distance in space doesn't just mean far away, it means fragile. It means every message risks dissolving into noise. And yet, against all odds, Voyager 1 remains connected to Earth, not by brute force, but by precision, patience, and one of the most carefully engineered communication systems ever built. Voyager does not transmit powerful signals. It cannot afford to. Its transmitter uses roughly 22 watts of power, comparable to a small household light bulb. That energy is focused by a 12-foot-wide high-gain antenna into a narrow radio beam aimed precisely at Earth. If Voyager's aim were even slightly off, the signal would miss our planet entirely. As the radio waves travel outward, they spread and weaken according to fundamental laws of physics. By the time Voyager's signal reaches Earth, it is so faint that it is buried beneath cosmic background radiation. Detecting it requires antennas of extraordinary size and sensitivity. This is why NASA built the Deep Space Network. 3 massive communication complexes, spaced evenly around the globe in California, Spain, and Australia, form a continuous listening system. Each site houses enormous radio dishes, some 70 meters across, capable of detecting signals that are effectively whispers from the edge of the galaxy. As Earth rotates, one of these antennas is always pointed toward Voyager, ensuring uninterrupted contact. These antennas do more than just receive signals. They filter out noise, amplify weak data streams, and reconstruct information bit by bit. But Voyager also needs power to transmit, and sunlight is far too weak at this distance to be useful. Instead, Voyager relies on radioisotope thermoelectric generators, devices that convert heat from the natural decay of plutonium into electricity. At launch, Voyager produced hundreds of watts of power. Today, that output has dropped significantly and continues to decline every year. To survive, engineers have carefully shut down systems one by one. Cameras were turned off decades ago. Backup instruments followed. Even internal heaters were disabled, forcing some components to operate far colder than their design limits. Despite this, Voyager keeps functioning. Over the years, it has experienced software errors, memory issues, and orientation problems that could have ended communication permanently. Each time, engineers diagnosed the issue from billions of miles away, sending carefully crafted commands that took nearly a full day to arrive. There is no room for improvisation. Every command must work the first time. That it still does is one of the most remarkable engineering achievements in space exploration. One of the greatest challenges in maintaining contact with Voyager 1 is orientation. The spacecraft must keep its antenna pointed at Earth with extraordinary accuracy. A deviation of less than a degree would cause the signal to miss Earth entirely. To manage this, Voyager uses tiny thrusters that fire in short bursts, gently rotating the spacecraft to maintain alignment. These thrusters were never intended to operate for decades, yet they continue to function nearly 50 years after launch. Over time, residue has built up in the thruster system, increasing the risk of blockage. To reduce wear, engineers updated Voyager's software, allowing thrusters to fire less frequently but for longer durations, extending their operational life. Communication delays make every action slow and deliberate. When a command is sent to Voyager, it takes more than 22 hours to arrive. The response then takes another 22 hours to return. A single diagnostic test can take days. There's no real-time control, no joystick, no second chances. Everything must be planned with absolute precision. Despite these challenges, Voyager continues to send back data from a region of space humanity has never explored directly. Its instruments measure magnetic fields, charged particles, and cosmic radiation, helping scientists understand the environment beyond the sun's influence. When Voyager crossed into interstellar space, its measurements confirmed a dramatic shift in particle populations, marking the true boundary between solar and interstellar domains. But Voyager's time is limited. Its nuclear power source continues to weaken, and within the next decade, there will not be enough energy to operate even the most essential systems. One by one, instruments will be shut down. Eventually, only a faint carrier signal will remain, and then, even that will disappear. Communication will end, not because of distance, but because the spacecraft can no longer power its voice. Yet Voyager's journey will not stop. It will continue moving silently through interstellar space, carrying humanity's fingerprint far beyond its place of origin. On board Voyager 1 is a message meant not for Earth, but for the universe itself. The golden record carries sounds, images, music, and greetings from our planet, a snapshot of humanity preserved in metal and time. It is unlikely to ever be found, yet it represents something profound. The belief that exploration matters even when no one is watching. Voyager will pass near another star system in tens of thousands of years. In hundreds of thousands of years, it will drift through the distant reaches of the Oort cloud. In millions of years, it will still be moving long after Earth's continents have shifted and human civilization has changed beyond recognition. The fact that we are still talking to Voyager 1 today is not just a technical success. It is proof that human ingenuity can overcome extreme limits. A spacecraft built with less computing power than a modern calculator is operating in an environment we barely understood when it launched. Signals weaker than almost anything we can measure are being captured, decoded, and turned into knowledge. Every transmission from Voyager is a reminder that exploration does not end at the edge of familiarity. It continues as long as we are willing to listen carefully enough. When Voyager finally falls silent, there will be no dramatic moment, just the quiet end of a conversation that lasted far longer than anyone expected. But by then, Voyager will have already accomplished something extraordinary. It will have shown that even across interstellar distances, connection is possible. That a fragile signal, guided by precision and patience, can survive a journey across billions of miles of emptiness. And that humanity, once bound to a single planet, has learned how to speak into the darkness of space, and for a time, be heard.